Okay, hi everyone. So we can't have class tomorrow via Zoom because my dog got hurt. And so I need to take Lucy to Cornell tomorrow during class time, but I refuse to get behind. So I'm going to videotape a little bit of what I wanted us to do tomorrow, and then so we won't be behind. So when we Zoom in on Friday, which you all are going to join me, and you have already watched this, then you can ask me some questions on it. But it's not too heavy, not too much stuff. So what you need to dig out, okay, what you need to dig out, let me share our screen a little bit. What you need to dig out is this paper right here, okay? You guys see it? The population density. So try to find that sheet. And we've already done the question on population density. I'll just write the formula just in case you don't have it. So population density is on the top is total number of people. Okay, and on the bottom, it's the total area. Remember, and you pop it into your calculator and you put it over 1. So you make a unit rate out of this population density. So we already have that. You already have that done. We've done this problem. What we haven't done, I don't think, is I don't think we filled this in. So remember, a rate is a comparison of two different quantities. So a rate is just a comparison of two different quantities. It's a fraction, right? It's a fraction where you have a different unit on the top that you do on the bottom. And we're going to do an example right now. And then let's do a unit rate. A unit rate is a rate whose denominator is numerically 1. So you take your rate that you've made and you pop it in the calculator and it becomes 1. All right. So this example I put in Blackboard. It's an example for rates, which is a special kind of ratio. So this is in Blackboards under, I think, handouts. And so you can print it if you want, or you can just follow along, whatever you want to do. So let's look at this one. So in 2010, the population of the United States was 311 million people. And the US population ate 12,040,000 metric tons of beef per year. Okay, do you see I put it in bold? It's like those charts that we were doing with the water consumption, the water footprint. So in the same year, the world population was this, and people consumed 56,544, there's that word thousand again, metric tons of beef per year. All right. So what was the United States consumption of beef per person? So that per, remember, means divide. So we're going to be making a ratio. And this ratio is going to be rate because the units on the top are going to be consumption of beef, and the units on the bottom are going to be people. So that's why it's called a rate. All right. So the US consumption. Put my glasses on so I can see what I'm writing. US consumption. Okay, now look, it's the total amount of beef. So there it is. It's 12,040, and then 1,000 means 3 more zeros. It's really 12 million. So this is metric tons per person. So we got to put it over the total number of people. And at that time, it was 311, so 311 million people. So there's your rate. But we want to do a unit rate because it doesn't say for every 311 million people. It says per one person, per person. So my calculator is across the room. So I'm going to use my phone. Okay, you ready? Tilt it on its side. Here we go. It's nice because you can see the numbers. So we have 12040 divided by 311, 1, 2, 3, 4, 5, 6. Okay. So it looks like each person, and they want to round it to 3 decimal places, 8.039. 0.039 metric tons of beef per one person in a year. All right, let's look at the world consumption. So world consumption, okay, ready? Now look, it tells you what to do. It's world consumption of beef per person. So we want beef on the top. So that's the 56,544, and then 1,000 is 3 more zeros. And then the number of people is 6,853,000. So this is tons of beef, right? And this is per total number of people. But they want it for one person. Do you see that? One person. So we got a unit rate on our hands. So pop this into our calculator. I'm hoping you're doing this too. All right. So we have 56,544, 23, divided by 6,853,000,000. So to 3 decimal places, 0.008 metric tons per person. So it looks like, in general, that the US consumes a lot more beef compared to the worldwide consumption. So the next question says, oops, sorry about that, couldn't see what I wrote. Next question says, how many times more beef is consumed per person in the US compared to the beef consumed in the world? All right, so it says, how many times more beef? So how many times more beef is consumed in the US? So remember how many times? They're asking you that. You put the big number on the top over the little number on the bottom. Big over little. All right. Let's pop that into our calculator and see what we get. So 0.039 divided by 0.008. So it looks like the US eats close to 5 times more beef than the worldwide consumption. Round it to 1 decimal place, so 4.9 times larger. All right, that's just a little review of rate and unit rate. This is a rate. This is a unit rate where you pop it in your calculator so that the value in the denominator is a 1 unit. All right. So again, this example's in Blackboard if you want to print it. The other things that we've been working on were absolute change and relative change. So I thought we should review that. So absolute change, remember, was the newest value or the most recent minus the older value. New minus old. This is how I think about it. New minus old. And if the absolute change goes from a smaller number to a bigger number, that's a positive. That's an increase. And if it went from a big value down to a little value, then it's a decrease. And we're going to look at an example in a minute. And the relative change, the formula, is the new value minus the older value all over the older value. And because it's a percent, make sure you multiply by 100. All right, so on Blackboard, this sheet is there. This is just another one. I said this is just going to warm up our brain a little bit with some of these examples. All right, so the minimum wage was set back in 2019 to be $11.80 per hour. And it said to increase to $12.50 per hour on December 31st, 2020. No, you can see this was an old problem from an old test. All right, so we're going from $11.80 to $12.50. So the absolute change is the new minus the old. So the new would be the $12.50. The old would be $11.80. So the absolute change, you guys do it on your calculator. You do it, I'll do it, okay? And we'll see if we get the same thing. New minus old, you guys do it. Pull out your calculators, just like we're in class. Did you guys get 70 cents? So it's a 70-cent increase. That's your absolute change. It's a 70-cent increase. Relative change is new minus old all over old. So it'll be $12.50 minus the $11.80 all over the $11.80. So on your calculator, make sure you hit enter before you divide by 1180, okay? Times 100. And it doesn't say to round, so let's round it. Oh, it does say 1 decimal point. So 5.9% increase. Just put increase. This is increase as well, because it's positive, so that means it's increasing. All right, so new minus old over old. So no and NOO. All right, so let's look at this one. If the new minimum wage set in 2021 was to increase by the same absolute change from the previous year, what will the new minimum wage be? All right, so this is the new minimum wage that's set in 2020. I don't know how accurate this data is. So this is the minimum wage set in 2020. And then in 2021, it said to increase by the same absolute change. So there was the increase from the year prior to get to this value. And then if it's going to increase again by the old absolute change, it's going to increase by another 70 cents. Okay, so pull out your calculator, tell me what you get. I wish we were together so you could tell me what you got. I'm going to check mine again just to make sure. So $12.50 plus 70 cents. Did you guys get $13.20? That is if it increased by the same absolute change. But it could also increase by the same relative change from the previous year. Okay? So let's think about how to do this one. So this is the minimum wage, the newest minimum wage. And if it increases by 5.9%, well, you're going to take 5.9% of this to see how much it's going to increase by. So 5.9% of 1250. What is 5.9% times 1250? Uh-oh, I think we're going to get a visitor. That's Leo. You see Leo? Sorry about that. Oh dear. Okay, Leo's got to scooch over. I'm not recording this again, so we're just going to get Leo out of the way. Sorry about that. Okay, here we go. Let's try this again. 5.9% times 1250. So did you guys get on your calculator? Now it says round to 2 decimal places. I got 0.7375, but if we round that to 2 decimal places, it would be 7. Here he comes again. 0.7. Oh dear, he's gonna knock over the camera. So sorry. Okay. Oh no, he's messing with my papers. Sorry, that's Leo. He's a very friendly cat that we adopted. He showed up at our house as a little kitten years ago. He's a big old fat cat. So if you round it to 2 decimal places, is that what you guys got? It's like a comedy routine here. Sorry. Check it again. Yep, rounded to 2 decimals. So we hope then that when things get increased, that rather than increasing by 70 cents, they'll use the relative change. So then it would be 1250 plus, if it increased by 5.9%, again, it's going to add 74 cents to it. So did you guys get the new minimum wage? Then would be $13.24. Right? So absolute change, relative change. This is an increase by the same absolute change, and this is going to be an increase by the same relative change. So we'll practice some more of those because there's definitely one on the test. We'll practice some more of those like when we're together next week. Maybe I'll start off class on Friday with one. All right. So let's finish off one more thing. So we ended class talking about a filibuster. And remember, a filibuster was a way that a group of senators can attempt to block or delay a bill or an action to come through the Senate. So it's what's called a filibuster. And you remember, a senator can stand up at length, talk about pretty much whatever they want to delay the bill to come to a vote. All right. And we said the only way to stop that senator from yippee-yapping is to have a vote come up that's called a cloture. And that's a procedure that can end a filibuster. And it takes 3/5 of the full Senate. The full Senate is 100 senators. There's 2 senators for every 50 states. So if you do 3/5 of 100, you get 60. So any 41 people, because that would only be 59 left to stop it. 41 people don't want the bill to come to the floor, it's not going to come to the floor. So they can keep the filibuster going, those 41 senators. So let's look at A and B, and then we'll finish this section will be done. Imagine that in July 2013, a group of senators who represented 21 of the least populous states in the US determined that a controversial bill is going to have a negative impact on their people that live in their home states. It says even though the bill would have a positive impact on the people that live in the rest of the country, these senators have to represent their states, and if this bill is not good for their states, they decided they don't want it to go to the floor. So one of the senators from this group begins a filibuster, and the others from this group refuse to vote for a cloture. They sit back and they say, nope, we're not going to vote for this filibuster to stop. Now look, there's 21 states times 2, that's 42 senators. That is enough to keep senators. That's enough to keep the filibuster going, because remember they needed 60 people to vote no to stop the filibuster. But if 42 people agree to do this filibuster, that leaves only 58 left. to vote it down, and it can't. You need 60. You need 60 to stop it. So it says, what percent of the total U.S. population benefited from the filibuster? Remember, these were 21 of the teeny states. So it says, as of July 2013, the population of the 21 least populous states was 35,607,000. And that's the U.S. population. So what percent? So remember, a percent is a part over a whole times 100. Right? Part over whole times 100. So the part is going to be the population of the least populous states. The whole is going to be the entire population of the U.S. at that time times 100. Right? Don't forget the times 100. So you guys pull out your calculator. Pull it out. I've got mine right here. You guys do it. I'm going to do it, and we'll see if we get the same thing. Plunk this in your calculator. Don't wait for me, right? Go ahead and do it. Be engaged with the material. So I got 11.3%. Check my answer. That's why I'm hoping you're doing it too. Times 100. Yep, 11.3%. So that means 11.3% of the population is going to benefit from this bill not going to the floor. That's a very small percentage of the population that is stopping this filibuster, right? That is not many people. So that means that close to 90% of the population would have benefited from it, that these senators are looking out for their state. Now, this is an interesting one. I like this as well. So it says 40% of the U.S. population turns out to vote. I hope that there's people strumming up this election in particular to get out there and vote, okay? So it says only 40% of our population turns out to vote. That's not very many. So let's see how many people turned out to vote. If it's only 40% of the U.S. population, I think we're supposed to use this right here, even though I know that there's children lumped in there, but this is going to give us an idea anyway. 40% turn out to vote. It'll give us the number that votes. Okay. So how many people voted? And in this election that they're referring to, less than half. This is what I got. You guys try it, check it. That's how many people voted. I'm going to check mine again. I got 126,451,600. Those are the people that voted in the last election. Okay? But then it says, it is also true that on average, senators are elected by approximately 60% of the people who turn out to vote. So when you go to vote, you don't have to vote in every single category, right? You could just click a couple, like say you just wanted to vote for the president, but you really didn't care about what was going on with the senators, so you just ignored that. So it says that of these people that voted, only 60% actually cared about who was the senator that went in and voted. So it says, it is also true on average that senators are elected by 60% of the people who turn out to vote. So 60% of that number care enough to investigate their senator and their platform and then turn out to vote. Okay. So what is 60% of that number? Did you get 75,870,960? So this is the number of people then who impacted who was our senator. That's the number of people that voted for senators. All right, this gets even crazier. So what percent of the population voted for the senators? What percent of the total population voted for the senators? All right, well, percent is a part over the whole. So these are the part of the entire population that came out to vote for a senator. Here's the total population times 100. Okay, you ready? You guys do it too. Make sure you fact check me. Did you guys get 24%? So as crazy as it sounds, 24% of our population voted for senators who controlled that bill from not going to the floor. So your vote counts. But that's a crazy thought, right? It says, what percent of the US population voted for the senators who kept the bill from coming to a vote? 24% of the population went out and voted for those senators. That's not many. So your vote counts. All right, so that is it for this section. We wrapped up that. And then we just have one more thing to do. So we're gonna skip section 2.7 and 2.8. That's gonna be on our next test. So the only other sections we have for this test are on mean, median, and mode. So we're gonna do section lesson 2.9 and then the next lesson after that. And then we'll be done for our test. So we will work on this on Friday. We will finish everything Monday. We're going to review on Wednesday and take our second test on Friday. So a week from Friday, we'll have our second test, okay? So this is on page 103. So we're going to put 2.7 and 2.8 on the next exam. It's on graphing. We're going to do that on the next test. So all I want to do today is just get into a little bit what mean, median, and mode are and how to find them. And then we'll pick this up on Friday when we're all together, all right? So just want to run through these examples and then do the example that's on the sheet that you have, this one, okay? All right, so to find the mean, that's what when I say mean, you probably think of an average. So whatever you think to find average, the mean is the same thing. Mean and average are typically the same thing. So to find the mean or an average, you add up the number of pieces of data and then divide by what they call n, and n is the number of pieces of data that you have. Okay? So on your calculator, you would add these up, which gives you 140, and then you're going to divide by 5. 5 is the number of pieces of data that we have. Okay? So for this, we've got 1, 2, 3, 4, 5, 6 pieces of data. We add them up, and we divide by the total number of pieces that we have. So the symbol that we're going to use for mean is X bar. And this is what it looks like. We're going to total the given data. And we're going to divide by the total number of pieces of data. So that's how you find the mean or the average, okay? And so just as a little a little clue. They said when you round for the mean, you always go one more decimal place than the original data. So since these are all to the nearest tenth, you're going to round it to the nearest hundredth, which is 2 decimals. Okay? Well, we're going to do an example together, okay, after we're done with this. The median is interesting. So for the median, it's a positional way to represent what's called the center. So the mean is one way to kind of have one piece of data to represent the entire data set. And so people talk about the mean, the median, and mode are ways to represent the center of the data. So an average is a way to measure what's called the center. The median is also a way to represent what's called the center of the data, and it's actually positional. So the first thing that you have to do when you find the median of a set of data is you have to put it in order. Okay? So step number 1, I'm going to highlight it. You need to write the numbers in order. Okay? So that's what they did on this line. They took the 18, 23, 45, 18, and 36 and just rearranged them. Now, if there is an odd number of data values, then the median is smack dab in the middle. So now look, these two are on the outside, and then I'm just going to work my way to the middle. So the median would be 23. So do you see that half the data values fall to the left of 23 and half of the data values fall to the right? So that's like the middle piece, splitting up the data values into 2 equal parts. All right. Now that's as if you have an odd number of data values. But if you have an even number of data values, right? So here's the set of data. Here they put it in order. So if we work our way to the middle, you stop at 2 separate pieces of data. So what you want to do, if you have an even number, is just find the halfway point. Find the middle of those. So add those together and divide by 2. So they get 12 or 20.5. So that is what's called the median. So do you see you have the same number of data values to the left of 20.5 as you do to the right? And the median is X with a little squiggle. That's what's called the median. That's the notation. So when we look at our calculators together, which we will, you'll see a little, I call that a little tilde. It's a little squiggle. That's the notation for median, especially when you take statistics. Okay, the last measure of center that we're going to look at is what's called the mode. And the mode is super easy to find. The mode is finding the number that occurs most frequently. So the bad thing about the mode is sometimes there can be things that are called bimodal, or you could even have something that has no mode. So that's the only bad thing about mode. But it's used quite a bit, and we'll look at examples where the mode is actually a nice piece of center to use to represent a set of data. All right, so here is a set of examples. Here's a set of numbers as an example. And you see that 18 occurs twice, which is more than any other number. So the mode is 18. So this one, they said, look, the 7 occurs 3 times, and the 10 occurs 3 times, and that's more than any other number. So there are 2 modes, 7 and 10. And typically, that is what is called bimodal. There's 2 modes. So it says the terms mean, median, and mode are well defined in mathematics, and each gives us a measure of the center of a set of numbers. In everyday usage, the word average usually refers to the mean, but be aware, average is not clearly defined, and someone might use it to refer to any measure of center. And that's the kind of thing that we have to worry about. And we'll talk about these misleading terms of average. And we'll talk about that together when we're on Zoom on Friday. All right. So we are going to work on the rest of this together on Friday. We're going to Zoom this together on Friday. So what I just want to do right now is just work through one example where you guys have to find the mean, the median, and the mode of this one. And then we'll start class with a little warm up with this one on Friday. Okay. So the first thing you have to do is you've got to put the data in order, right? That's first thing, very first thing. So it says find the mean, median, mode. So let's go ahead. It takes a little while. You might want to just pause the video instead of watching me do it. But I'm going to go ahead and I'm going to put the data in order. So it looks like, I don't think there's any stuck in there. So it looks like the smallest piece of data is the 76. So I have a 76 here and a 76 there. And then the next one would be 77. And then the next one, 79. So I think I took care of all my 70s. And then I have an 80. No 81, but I see two 82s. No 83, no 84, but I see an 85 and an 86 and an 87. 85, 86, 87. I see three 89s. And then a 92. All right. So the mean. Add them up and divide by the total. So 2, 4, 6, 8, 10, 12, 14. So when you add these up, hit enter at the end and then divide it by 14. Okay, you do it. I'm going to do it. We'll see if we get the same thing. I'm going to do it twice to check my work, but I highly recommend that you do this with me. Two, 4, 6, 8, 10, 12, 14. So the first attempt that I did it, I got 83.5. And that makes sense, right? Because it falls within the range of my data. Like if I had gotten something that said 47, that wouldn't make any sense because this is supposed to be a representation of this data. So I'm going to try it one more time just to make sure. I see this is why I need us to be together so I can fact check with you guys. What'd you get? What'd you get? What did you get? I miss being able to do that. So I'm going to fact check it again just to make sure. Got 83.5 again. So I'm thinking we did good. All right. So there's the mean. The median is the middle. Now there's an even number of pieces of data. So I'm going to work my way to the middle. Okay, so it's the 82 and the 85. So if I add those two together and divide by 2, I get 83.5 again. So that just happens to be the same value. So right here at 83.5, there's the median. So look, so do you see the same number of pieces of data fall to the left as to the right? 1, 2, 3, 4, 5, 6, 7 fall to the left of that. 1, 2, 3, 4, 5, 6, 7. In that position, half the data values fall to the left, half fall to the right. And then the mode is super easy, right? It's just the piece of data that has been repeated the most. Looks like 89's it, right? 89 is that piece of data that was used 3 times, and that was the most frequent occurrence. Okay, so Friday, when we're together, we're going to finish this one. And we're going to talk a little bit about mean, median, and mode. And then we will finish up that packet. So the only other thing I want to do is just remind you that you have an oh wow. So if you were in class, I gave it to you. If you, and a couple people left before I could give it to them. So listen, if you didn't get an oh wow, I'm going to post this on Blackboard under a tab called oh wow. And so then you can, if you don't have a printer, that's fine. Just write it on a separate sheet of paper and bring it on Monday, because I'm hoping, of course, we'll be face-to-face on Monday. So bring your oh wow on Monday. But you should be able to handle it all now. You should be able to do all of these questions. Just remember that this one, we're going to spend some more time with on Friday. So I will see you on Friday. Stop sharing the screen so I can see you. So I will see you guys on Friday. I'm very sorry I can't Zoom tomorrow, but I will be up at Cornell with my puppy. And if you have any questions, let me know. Otherwise, bring questions in on Friday, and we will finish this section up on averages and mean, median, mode when we're together. All right? Take care, everyone. I will see you on Friday. All right?